are a little over 10 minutes away from the loss of signal, so we will be focusing our attention to the control room very soon now. But before we do, let's take a moment to chat with JPL Director Mike Watkins. So, Mike, how are you feeling?
Well, first, good morning.
Yes, very early morning.
We always tend to do these events somehow at 3 in the morning or 5 in the morning.
Why did we do that?
But, you know, it's kind of a bittersweet event for all of us, I think. For me personally, it's more sweet than bitter because Cassini's been such a fantastic mission. But I think, you know, one of the important things about these events is to celebrate the incredible hard work, the decades of hard work of the team that designed, built, and operated Cassini. And that's really, right, the heart of the spacecraft is really the people that worked on it, and the people that have been operating it. And this is a great time to celebrate that level of dedication, that devotion, you know, to work on something for 10, 20, 30 years. That's sort of unparalleled in human history.
So how do you think Cassini will be remembered in the science books?
Well, I'd say most of the science books, most of what we have in science books about Saturn come from Cassini. Right. So it will be long remembered. I mean, if you look at almost everything we know came from Cassini about Saturn. But, you know, I think one of the greatest legacies of a mission is not just the scientific discoveries it makes and what you learn about, but the fact that you make discoveries that are so compelling that you have to go back. And that's really the part of what makes the end of Cassini sweet, is that the discoveries are so compelling that we have to go back. We will go back and fly through the geysers of Enceladus, and we'll go back and look at Titan, because it's just the Cassini findings are they're just groundbreaking.
But the way missions are, one mission sort of sets the footsteps for the next mission. So what's coming up next after Cassini?
So one of the things we've learned about the outer solar system is how much water is there. So we used to think that most of the water was here in the inner solar system. Here on Earth, for example, habitable zone, Goldilocks zone between Venus and Mars, where we are. We now realize that there's a lot of water in the outer solar system. So Europa, for example, the moon of Jupiter, Enceladus. And I think what you see compelling about the outer planets is to go back and look at those ocean worlds in great detail. Fly through the geysers, try to drill down through the ice, take a look at the composition of the ice. And as Jim Green noted, you know, are these habitable places? Are these places where there could be life? And so we here at JPL and NASA, we have plans to go back to many of these ocean worlds, as many as we can. The next one up is a multiple flyby of Europa. We call Europa Clipper, where it'll be in orbit around Jupiter and fly by Europa 40 or 50 times, and taking a very close look at that ocean and from above the ice, of course, and the composition of the ice. And then later we'll make our way to the other ocean worlds. Ocean
worlds are the things to look at right now, it seems.
Absolutely. We know the search for life is one of the compelling threads for NASA and for the Science Mission Directorate and for JPL. We're looking for life in our solar system, and of course we're looking for life outside the solar system. We're looking for exoplanets and other Earths. But the ocean worlds look like an incredibly compelling target.
All right. Well, thank you so much, Mike, for coming by and joining us. I know all the guys want to get back in there in the
Absolutely.
Control room and be there for the moment.
The last few minutes.
All right.
Thanks, Kay.
Thank you so much. You're watching live coverage of Cassini's final hour from NASA's Jet Propulsion Laboratory. JPL is located in La Cañada, Flint Ridge, and Pasadena, and managed by the California Institute of Technology. Let's take a look at our last hour display. Our display shows that we are just over 7 minutes away from the end of mission. And it's now traveling about 75,000 miles per hour. So Cassini is traveling rapidly towards its end of mission.
For all the beauty and the exotic features that we found, those are places that startle and amaze, but not a place where you can live. And I think it gives you a perspective on the Earth and what a wonderful place it is, and more impetus to perhaps take care of it.
We are getting close to time, and at the time where we should lose that signal. Folks are watching the radio science display right now, so let's go to Todd and Joni in Mission Control.
Hi, Gay. Well, 6 minutes to go till we're 6 feet under, so it's going to be hard to say goodbye here. Radio display still looks great, as we just saw on screen. Mission Control, I hear a lot of buzz in the room about the thruster cycles because the thrusters are firing. We're still outside the atmosphere, and they're just keeping deadbands, keeping that pointing on Earth as long as possible. So things aren't too crazy yet, but once we hit that atmosphere, things happen super fast. So let's look around the room.
This time ACS is nominal. We're in low rate mode and we're waiting for high rate mode transition.
Copy,
So-
thank you.
So that was
ACS fault
indicate.
protection systems lead.
Go ahead, system lead.
Just going to get a quick subsystem status, please.
AECS fault protection is nominal.
Copy, thank you. Thermal systems lead.
Thermal devices subsystem is nominal.
Copy, thank you. Power systems lead.
Power subsystem is nominal.
Copy, thank you. System fault protection systems lead.
System fault protection is nominal, no fault protection activity.
Copy, thank you. CES systems lead.
CDS is nominal, we have 2 frames buffered.
Copy, thank you. Telecom systems lead.
Telecom is nominal. Good SNT.
Copy, thank you. Radio science systems lead.
Radio science is nominal, signal levels are nominal, the residual frequency is starting to increase.
Copy, thank you. Propulsion systems lead.
Pressures and temperatures are nominal. Propulsion is nominal.
Copy, thank you. Mission planning systems lead.
Mission planning is nominal.
Copy, thank you. Flight director systems lead. Everything is nominal.
Copy.
And Ace copies.
Thank you, Ace.
So what we just heard was the room going around and checking all of the subsystems. So far, all of the subsystems are nominal, about 4 minutes, 3.5 to 4 minutes away from the end.
Joni, I heard a comment there that we went from low rate to high rate control. Can you comment on that?
Sure. So we have our computer that's controlling our pointing has different modes, and it's smart enough to know when we start having to fight a little harder. So we heard that the computer acknowledged that we start having to fight a little bit.
Okay, thanks. We were remarking earlier, it's incredible. This entire spacecraft runs on 600 watts of power. How much power is that?
Yeah, about half a hairdryer.
Wow.
That's all we got right now.
I won't even talk about how little fuel we have left. It's about 1% plus or minus 2%. So that's one reason we're heading into Saturn's atmosphere tonight. Under 3 minutes now. We should definitely emphasize we don't know exactly when we'll lose signal. It depends on the Saturn atmosphere and how well the thrusters fight. So stay tuned.
And
Radio signal looks wonderful. X-band and S-band, 2 different radio bands, still getting the signal from Cassini.
we're approaching about 10 degrees north latitude on Saturn. "3,000 miles from the cloud tops.
I remember seeing we were going to hit the atmosphere about 77,000 miles an hour. I see we're close, so. Two minutes and counting.
Oh, we're starting to exit the...
Systems, this is ACS1.
Go ahead, ACS.
We're still waiting for transition to high rate mode, but it looks like we're going to start accumulating thruster on time at a higher rate now, and our attitude control error is starting to be more active.
Copy.
That means we're just starting to sense the atmosphere, right?
Yep. We can start seeing the spacecraft starting to lose the battle with the atmosphere.
Systems ACS1, we just had the transition to high rate mode, and with this we're going to start seeing thruster on time accumulating very quickly, and the deadband is going to clamp down to 0.5.52 millirad, and we are in the atmosphere.
Copy, thank you.
Roughly 1 minute to loss of signal.
Systems, this is Nav.
Go ahead, Nav.
We can confirm what AACS just told you.
Copy, thank you.
So we're just starting to see the thrusters fire more and more. Yeah, everyone can.
Radio signal still holding. 30 seconds.
Systems lead, mission planning.
Go ahead, mission planning.
Spacecraft has just crossed 10 degrees north latitude, altitude 1,000 miles.
Copy, thank you.
Systems, ACS-1.
Go ahead.
With the additional thruster on time, we're going to also see the deadband start riding.
Copy.
Oh, yeah.
We've crossed our 0 time. We let Tracy call it.
Flight Director, Ready Science.
Go ahead, Flight Director.
We have lots of signal at X-ray band and zero band.
Project Manager, Flight Director.
Go ahead.
Okay, we call loss of signal, loss of X-band at call loss of signal at 115546 for the S-band, so that would be the end of the spacecraft.
That. Project Manager on FSO Quard. Maybe a trickle of telemetry left, but just heard the signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project Manager, off the net.
So just a short time ago, Julie Webster, the Space Operations Team Manager, and Program Manager Earl Mays called it the end of mission for Cassini. It came at about 4:55 as predicted. Let's go now to Beckman Auditorium and check in with Morgan Cable. She is with Cassini interdisciplinary scientist Jonathan Lunine to find out how the scientists are doing and the team is doing down there. The mission is certainly not over for them because now there will be tons of data for them to be poring over. Morgan?